In this video, we're going to take a look at another very common interview question that you'll see very frequently around linked lists. This is another question that's going to utilize that kind of two-reference system to come to a pretty straightforward solution. So let's take a look at this one because, again, very common to see in an interview setting. Inside of my code editor, I'll find the circular directory. I'll open up the index.js file. And then before I forget, let's also start up our tests at the command line. So inside my exercises directory, I will run jest circular test.js -- watch, like so. And then we should see about 4 tests right now. So here's 4 total. Cool. All right, let's take a look at this thing. So circular says, given a linked list, return true if the list is circular and false if it is not. So clearly the keyword here to understand is the word circular. So let's talk about what a circular linked list is. Remember that up to this point in time, we've always said that a linked list has a head, which is the very first node of the linked list, and a tail. And the tail node can be identified because it points to a value of null, which means that's the end of the list. In a circular linked list, we do not have a tail node. With a circular linked list, we would have a tail node, or kind of a last node, so to speak, or what we might imagine to be a last node, that maybe accidentally points at an earlier node within the linked list. And so this is a diagram of a circular linked list right here. Circular linked lists are a huge problem because, as you recall from all of our linked list problems we've been working on, we wrote a ton of for loops that all assumed that they would eventually find a node with a next value of null. So if there's no element in our linked list that has a next value of null, then we would end up with a ton of infinite loops. So all those while loops that we wrote, they would all be infinite in nature with a structure like this, because we would iterate from green to blue to red to orange to purple, back to red, orange, purple, red, orange, purple, again and again, and they're never going to find a value of null. So our job is to write a function that's going to detect this situation right here. Now the first thing I want to say is that you might be thinking, okay, well, let's iterate through the linked list, and then we will have a counter variable. And maybe as soon as that variable gets up to like 10,000, we'll say, oh, this is too long, it must be an infinite list or something like that. Well, unfortunately, that's not going to fly in an interview setting, right? We need to say very, like 100% confidence, we need to be able to say, yes, this is a linked list that is circular, or no, it's not. And we can't just assume that if the list is really long, then it must be infinite. That would not be a good approach. The other thing that you might immediately think of is that, well, maybe we could iterate through the linked list, and for every node, we could add some property to it. Something like, I don't know, a .visited flag or something like that to every node. And then we can iterate through it, and if we ever see a node with that .visited property, then that means we've already been there one time. Again, that's a solution that would probably work, but in general, with any data structures like this, you never want to be adding additional properties to a node. That's really just not a good approach, and something that I really recommend you not do in an interview setting. So those are 2 simple solutions that people come up with. Let's talk about what might be seen as the real answer. Again, this is another one of those problems where you've either seen the solution or you haven't. And luckily you're here, so you get to see the solution. So again, we're going to use 2 separate pointers, and we're going to use them to iterate through our linked list at different speeds. So we're going to initialize slow to look at the first node, and we're going to initialize fast to look at the next node. Now here's what we're going to do. Again, we're going to say if the next 2 nodes after fast are defined, then we're going to enter into a for loop. Inside the for loop, we're going to move fast forward by 2 nodes. So fast would now be looking at red. We will then move slow forward by 1 node. So slow is now looking at blue. After moving these 2 nodes forward, or these 2 pointers forward, we're then going to do a check. We're going to say, are slow and fast looking at the same node in our linked list? So we're going to do a strict triple equals comparison between the 2. We're going to say, are these 2 variables right here pointing at exactly the same object? If they are, well, okay, that's going to be kind of interesting, and we'll talk about what that would mean in just a second. Otherwise, we're going to continue iterating through the list. So with the next step, we will check to see if the next two nodes are defined for fast. They are, so we're going to move fast forward by 2. So 1, 2. And then we're going to move slow forward by 1. Now again, we're going to ask ourselves, okay, are these two looking at the exact same node? And again, no, they are not. So we're going to iterate again. We're going to move fast forward again by 2 nodes. So we go to red, that's the circular part, and then we move on to orange. So here we are pointing at orange now. And let me get a better arrow here so it doesn't look so crazy. There we go. So fast is looking at orange, and then we're going to move red forward by 1 as well. So now slow and fast are both pointing at orange. We check to see if slow and fast are pointing at the same node. In this case, they are. And because they are pointing at the same node, that means that we must have a circular linked list. So in other words, we iterate slow forward by 1, fast by 2. At every step of the way, we check to see if they're looking at the same node. If they are, well, then that means we must have a circular list. If they're not, then we continue iterating. And we repeat this process until either slow and fast are looking at the same node, or the case in which fast is looking at a value of null again. Because remember, if purple node right here, let's look at an example of that. So if the purple node was correctly pointing off to null, presumably somewhere over here, off to the right, well then when fast was looking at orange or whatever the heck it was looking at right here, we would say, okay, fast is the next node null, or the one after that null? And in this case, yes, it is. 2 forward is null, so that means that there is an end to the linked list. And so we would return false in that case. So that's pretty much how the solution works. Again, we make the 2 separate variables and we advance them both forward, one at 1 at a time, the other at 2 at a time, and then we compare the value between the 2 of them at every step along the way. So this is going to be another problem where there's really not a lot of code to it. It's just another one where if you know the solution, you can solve it pretty briefly. Otherwise, you're going to be kind of flailing around for a little bit. So I encourage you to give this a shot. We'll continue in the next video, and we're going to look at a solution together.